Lesson 48 is on the discriminant and complex numbers. Discriminant, well, here is the expression for the discriminant, b squared minus 4ac. That's basically, if you think quadratic formula, that's what's inside that square root there. Although the discriminant doesn't have the square root symbol there, that radical function there. So we have b squared minus 4ac. What this determines, it determines the number of solutions that we have. Now, if you think of quadratics, quadratics is basically finding the x-intercept. So that quadratic formula finds our x-intercept. What this does is it tells us, the discriminant dictates how many x-intercepts our graph has. So if you look at the table below, they give us three equations here. Here's our three equations. When graphed, well, they're graphed below. Notice this first one has two x-intercepts, so therefore it has two solutions. When you put in your a and c values and you get a positive answer, such as a positive 4 that we took from our equation up here, when it's a positive outcome, you have two real solutions. That's telling you that your parabola is going to intersect your y-axis in two spots. If you have one solution right here, and you put in your b and ac values, and you come up with an answer of 0, that's telling you that you're going to have one solution. Your parabola is going to intersect the spot at one graph. Finally, if you have an equation in the last example here, notice our graph does not have any x-intercepts. So you come up with two imaginary solutions. Okay, they do not have the x-intercept at all. Two imaginary solutions. You get a negative outcome. So when you get a negative outcome, it's saying that you have two imaginary solutions, which is basically telling you it does not intersect the y or the x-axis. That being said, imaginary, I. The imaginary unit where I equals the square root of -1. Basically what this is telling you is I equals the square root of -1. If you have I squared is going to give you -1. Okay, so remember that. Anytime you have I squared, -1 is your outcome. If you just have the term I is basically saying the square root of -1. So, we need to simplify these problems. The square root of -81. If you tried it in your calculator, you couldn't get an answer there. It wouldn't allow it. So what we need to do is go ahead and break this down. Well, basically what the square root of -81 is saying is 81 times -1. So we could also look at it like this. The square root of 81 times the square root of -1. The square root of 81 times, well, the square root of -1 here, as mentioned above, square root of -1 is known as I. So I can say the square root of 81 times I here, and what I would get, well, I could figure out the square root of 81. That would be 9I. Square root of 81 is 9. Look over in B here. Same scenario. Same scenario like in an A. Well, I'm going to break it down. We have 56 times -1, which is basically saying the square root of 56 times the square root of -1. That square root of -1 is I times, well, the square root of 56, we're just going to go ahead and leave it square root 56. Okay, because that's exact. If you figured out the square root of 56, you would get some decimal there, and we're not going to deal with the decimal right now. Another way you could actually do this, if you think about it, is if you were to reduce it, you could say that, well, the square root of 56 is 2 times 2 times 2 times 7, and then we'd have times I here. Now, when you think about this here, we have a pair here. 2 times 2 is 4. The square root of 4 is really 2. So I moved that to the outside because the square root of 4 is 2. Inside my square root, I still have 2 times 7, which is 14, and that would be 14I. So this is actually mathematically math script that would be the best possible answer. I would also probably accept this here as well. We'll get into this phase here shortly. Last one, we have 30 times I squared. Well, we know I squared, as stated above, is -1. So this is really saying 30 times -1, which is -30. Example 2 here, I'll work through A, then I'll have you work through B, but find the value of the discriminant and describe the number and type of solutions it has. Remember, to find the discriminant, it is B squared minus 4AC. So we need our A value, which is 4, our B value, -28, and our C value is 49. We're going to go ahead and plug that in to the discriminant. So we get -28 squared minus 4, in for A is 4, and in for C is -49. We wind up with 784, take away 784, which is going to give us 0. If you looked back into your table, basically when you come up with an answer of 0, that is telling you that you have one real solution. One real solution is telling us that it has one x-intercept. So this parabola, if we were to graph that parabolic function, it would intersect the x-axis in one spot. I'm going to go ahead and have you work through B here. In order to work through B, remember, we have to set this equal to 0, that equation. Set it equal to 0. So subtract x from both sides. Rewrite it, and then go ahead and fill in your A, B, and C values. Check back in after you finish. A, B, and C values. A is 1, B -1, C is 1. Plug those into the discriminant. Here's what it should look like plugging into the discriminant. And then we would have 1 minus 4. 1 minus 4 gives us -3. So we have two imaginary solutions, which is basically telling us that it has no x-intercepts here. In example 3, what they're having us do is state whether the discriminant is positive, negative, or 0 solutions. Remember, if it's positive, negative, and 0, it's going to dictate how many times it crosses the x-axis. In this case, in 3A here, we do not cross the x-axis. So if you were to actually work through the discriminant using this criteria here, you would find out that you would come up with a negative answer here, because it does not cross it. It would have two imaginary solutions. Down in B, if you use the criteria, pulled out A, B, and C and put it in the discriminant, we see that our graph does intersect in two spots here. So therefore, when solved, we would have a positive discriminant. Last example here, example 4, it says solve using the quadratic formula. So we're going to solve using our quadratic formula here, and you're going to get a little taste here to see what happens when you have a negative inside your square root and the process that you need to take in order to solve. First things first, nothing new here. I went and solved and set everything equal to 0, so I'm able to now go ahead and pull out my A value, which is 1, my B value 6, and my C value 13. Now I'm going to use this, go ahead and put it into the quadratic formula here. Remember, that is x equals negative b plus a negative square root b squared minus 4ac, and this would be all over 2a. So we need to go ahead and substitute those values into that quadratic formula. There's my substitution after I put everything in for the corresponding variables. Next, I'll go ahead and simplify. We get x equals negative 3 plus a negative square root. Here we have 36. Take away 52 all over 2. So x equals negative 3 plus a negative. Inside my square root, we get negative 16, 36 take away 52, still all over 2. Now, what we have inside our square root is a negative number. So instead of using that, we can look at it like this. This is negative 3 plus or minus, right? So we have basically the square root of 16 times the square root of negative 1. I took out that negative 1, still all over 2. Your last and final step would be negative 3 plus a negative. Well, the square root of 16 is 4, and the square root of negative 1 is I. This would all be over 2. And again, we can reduce again that fraction, x equals negative 3 plus a negative. 4 divided by 2 would give me 2i. And we'd have to leave it like this because that is the imaginary numbers there that we're working with. We don't know what I is, so we can't say negative 3 plus 2i and get an answer from there. You can write it, I would write it exactly as I have it here. This is also a possibility. Negative 3 minus 2i. That's basically what happened there. I would just go ahead and leave it as such, and that will cover everything. So those would be your imaginary intercepts. This will conclude lesson 48, discriminant and complex numbers.